Hi my dear students. So in this lecture we will discuss about the Dijkstra algorithm. Right. So before discussing to the actual content of the Dijkstra algorithm, we will discuss about the fundamentals of Dijkstra when it was introduced. So what is the main motivation of Dijkstra algorithm, and at the end of this lecture we will discuss about the one example and followed by the time complexity of this algorithm. First of all, what is the Dijkstra algorithm? So also in our call it as a single source shortest path algorithm, right? Single source means we have one source, from there we have to find the source. So one source to we will find the remaining places. We find the minimum or shortest path from this one source to the destination. So this we call it as a single source shortest path algorithm. So it will use the greedy approach. So greedy approach it will follow, right? So what it will do? Dijkstra will help to find the shortest path between the pairs. Points means there is a one point. So we will come to know what is the point and where we can use that. We will we will clear with the example. So it is used in a graph, right? So what is a graph? Graph is a consists of vertices and edges. So most of the students in this already know what is a graph, right? So network is a connection, nodes and connections. So what is a node? So this one we call it as a node, this one we call it as a connections. So these kind of architecture we are going to use the Dijkstra algorithm for finding the shortest path, also called as a single source shortest path. It was created by Dijkstra at the 1956, right? So it will work only when all distance are weights. So that means that weighted graph only this problem will be solved. That too, and one more drawback also, it should be positive. So that means that if it is one node to the another node, there must be weight should be associated, and same time it should be the positive weights. So then only it will work. So one of the drawback of Dijkstra, it will not work in negative edge weights. So this is the one of the drawback related to the distance algorithm, right? So next we will see the where we can use the Dijkstra algorithm. So we can use the GPS navigation for finding the shortest path in a road maps. Next one, internet routing. So internet routing means sending the data in efficient manner. Like for example, data is transferring from one source to the destination. Usually we will refer the shortest path. So data will be always transferred to the shortest path. So we will not prefer the longest path. So next one is one on social networks also we can use. So finding the shortest connection between the people. So airlines also we can use. Natural cases is a natural scenario. Even airlines and data transformation, social network, GPS. Always we want to minimize the minimum distance between one source to the destination. So these are the basic funda behind the Dijkstra algorithm. Next, so basic terminology. So this graph is made up of vertices and edges. Right, so graph we already seen vertices and edges. So this is the basic fundamental required to understand the Dijkstra algorithm. So each connection has weight. So that means that, for example, this is the one nodes. We have one edge between the one graph. This is A, this is B. Let us say this is the edge weight. So it must have some weight, 10 units of time. It may take time or cost or kilometers distance, like that you can take. So which may be cost or time, anything. So I hope you understand what is the discuss the algorithm is meant for. So now we will see the one example so that you will understand the clear about discuss the algorithm. So I am constructing one diagram so that you will understand the clear example how it will discuss the algorithm is working, right? So now what is the idea about this author is where he is standing from his position to the other position. He feel that it is a, if it is link is there, then it is, he will feel that it is a distance is known. If it is not, link is not known, then it is, he will understand that it is a infinite distance. So that means that it doesn't know what is the distance between the one node to the another node, right? So that is the motivation he made and he developed the algorithm, right? So that is one of the fundamental concept in a discuss the algorithm, right? So now usually in a real time scenario also where we are standing, for example I am standing at this position 1, let us say position 1. So naturally what is the distance between myself? So for example you take, this is the example we are going to solve. For example I am at location 1. So what is the distance between the 1 to 1 again? So naturally 0. So this is the fundamental concept to develop the discuss the algorithm. And what is the distance between the 1 to, here you can see 1 to 6, 1 to 3, 1 to 7, right? And 1 to 5, 1 to 4. Initially it doesn't aware about his path. So that's the reason what he is assuming is distance is infinite. So later starting exposure, he will come to know what is the exact distance between. So that is the major intuition for developing this algorithm. For example, if scientist we are at a location 1 to 1 again it is a 0, and I am not aware about the location about distance about 1 to 6, 1 to 3, 1 to 2 and 1 to 4, 1 to 5. I am not aware. So if I am not aware, what I feel, definitely I don't know about what is the distance between the my location to the destination location. So that's why I cannot determine how much it is. It is a far or near or longest distance, nearest distance. How much is, I cannot measure it. So that's the reason he made it a infinite. That is the second point. First point, myself distance, again my where I am starting, I am ending same, that is a 0. Where I am going, remaining is a infinite. This is the one of the key point for developing the discuss the algorithm. So there is a one motivation to develop this one, like what algorithmic concept we will discuss later on, but these two fundamental ideas, that is one is 0, what is infinity, remember. So at the end we will discuss the algorithm, then we will understand the how it is algorithm work, same concept, right? So now we will see, we have seen already example concept. Then so we make a one target, what is source where I am starting, and make a table like this, and make a destination. So destination is remaining destinations, right? So what is the source? Source is a 1, what I am starting 1. So destination is a 2, 3, 4, 5, 6, 7. So let us say this is a destination, right? So in this one source, what is the source? Source is a 1, right? Now you can see, so 1 to initially, so I am in position 1, I am not aware about this path 1 to 6, 1 to 3 and 1 to 2, I am not aware. So that's the reason what I will do, I will assuming that a distance from 1 to 6, 1 to 3, 1 to 2, everything I assuming that it is a infinite, alright. So in the infinite, so I will create here distance 1, 1 to 2, infinite, 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 infinite. So this is the first step. So later what I will do, I will at one position, then I am start exploring the connections which are having edge to the vertices 1. So that means that you can see here. So 1 to 2 have 1 to 3 have edge, 1 to 6 I have edge. So what I will do, I am assuming that there is a edge associated with vertices 1, 1 to 6, 1 to 3, 1 to 2. So I am known to the 1 to 6, 1 to 3 and 1 to 2. I will understand that these are the edges weights already known. So remaining I don't have any direct correction to the one, remaining I kept as it was there. So now in that position what I will update here. So 1 to 2, what is the distance? 1 to 2, 7, right. 1 to 3, what is the distance? 9. So 1 to 4 I don't have any connection, direct connection. 1 to 5 I don't have any connection. 1 to 6 also I have 14, right. So 7 is there, 7 is not there I think so. 7 is not there, sorry, I am wrongly written this 7 is not there, right. So still it is 6 only. So I am starting 1 to 6. So 1 to 2 is a 7, you can see here. 1 to 2 is a 7, 1 to 3 is a 9, 1 to 6 is a 14, 1 to 5 I don't have, 1 to 4 I don't have direct connection. Connection is there but I don't have direct connection. So that's why I written 1 to 2 is a 7, 1 to 3 is a 9, 1 to 4 is a infinite, 1 to 5 is infinite, 1 to 6 is a 14 I written, right. So now our 7, 9, infinite, 8 and 14. So which is a minimum? 7 is a minimum. So pick the 7. So what he is trying to find is, he is trying to find distance from one to the other location which is a minimum, right. So once he found the minimum distance, he will get relaxed that node. So it means that if it is found the distance from real time case, if we found the distance from one location to the other location, we already know, we explored the all paths, came to know, after exploring the all paths, we came to know that these are the minimum paths. So when it is another time, we are exploring the same place, or you are teaching to someone else, definitely you will say these are the path you already found it is the minimum path. So you will not change the again to the other location. So that is the one of the meaning of relaxation, right. So I will tell you the relaxation code also. So now you will relax the 2, right. So 2 you will relax, 7 is a minimum, that's why you will relax. Then you write 1 comma 2. 2 is associated with this node. So that means that you are found the location shortest distance from 1 to 2 which is a minimum, right. So next what we will do after that one. So now what we will do, 1 to 2 you found minimum, from 2 you can try to explore the other paths. So from earlier we don't have 3 to 4 we don't have connection, so that's the reason for a reason. So we explored the till the position 2. So 1 to 4 you can write by using the 2, right. So update this information into the table, right. So now here 7 will be remain same, 7 we don't have change, we are already relaxed. 9 we already found, so there is no other path. So that means that you can see here. So we are at initially 0 position, we are at the second position, right. So from the second position we are trying to find the some more minimum paths from other nodes. So 2 to 3 we don't have any connection, it will not update previous one. 2 to 4 we have connection. right? 2 to 4 we have connection. So by using 1 to 7, 7 to 5, so 7 plus 15, it is a 22. So that will be updated into the table. So that is the 22. Here it is a 22. 1 to 5 we don't have 1 to 5. 1 to 5 we don't have any direct connection via 2. So that's why we return infinite again. So it will be 14. It will be remain same. 1 to 6 we don't have any changes at 1 to 6. Why? Because I return 14. So 1 to 2 we found, but 2 to we are not going to the 6. So that's the reason it will be remain same. Only change will come in a 4 place. So that's why I updated. So next, so our 7 we already relaxed, 9, 22, infinite and 14. Which is a minimum? Minimum is a 9. So that means that you relax the node 3. So you write 1 comma 2 comma 3, right? So next 7 is already relaxed, right? So 9 is again 9 is already relaxed. You write from 1 to 2 you selected, 3 also you selected. So from 3 to you try to explore the other paths. Try to explore the path. So you 1 to 2, 2 to 3. So this one you explore. So next update the weights. So that means that so 1 to 2, 2 to 4 we updated previously, that is the 7 plus 50, 22. But we got 3 is the best one. You can reach 1 to 3, 3 to 4. So that is what is the weight? 1 to 3 is a 9, 3 to 4 is a 11. 9 plus 7, 20, right? So 20 means previously it was 22, but we got a minimum path which is a 20. So where is the 22 is there? You update the 20. If you have any alternate path which is existed, better than existed one, that to minimum. So that means that for example this one, see this one, this is a 22. 1 to 4 is a 22 previously, but we got 1 to 4 is a 20. Previously it was 22, but now alternate paths we got 1 to 3 is a 9, 3 to 4 is a 11, which is a 20. So now compared to the 22, 20 is the lesser values. That means the minimum value. So you update here, it is 20. Okay. So next 1 to 5. 1 to 5. So now you check 1 to 5. So 1 to 5 we already explored, 1 to 2 explore, 1 to 3 explore, but we don't have any connection. So you keep as it was there, infinite only. Right. So you put infinite and 1 to 6. So 1 to 6, 1 to 6. 1 to 6 previously it was 14. You check any alternate path is there via 2 or 3. Right. So 1 to 3, 9, 3 to 6, it is a 2. So 9 plus 2, 11. Previously it was 14. So 11 is a better than 14. So update that value to the 11. Right. So now, so 7, 9, 20, infinity, 11. So which is the minimum? 7 is obviously minimum, right? But we already relaxed. Just ignore that one. 9 also minimum. Second highest minimum. So that is also relaxed. So think about which is not relaxed. So 20, infinite and 11. Which is the minimum? 11 is the minimum. Get relaxed 11. So then you write 1 comma 2 comma 3 comma 6. Right. So next 7 you write as it was there. 9 you write as it was there. Now what you relax? 1, 2, 3, 6 you relax. Right. So next what you do? You try to explore. Here it is a any alternate path is there. 1 to 4. 1 to 4 via 1 to 3 already relax. 2 already relax. 6 already relax. So you have only 2 weights, that is a 5 and 6. You check the any other paths via 2, 3, 6 are existed with the minimum path which are already written in the table. Right. So now if you see this one in 20 will be remain same, but 1 to 5. 1 to 5 means So 1 to 5 we already relaxed 6, right? So 9, 1 to 6 is a 14, 14 plus 9. 14 plus 9, what is the value? 14 plus 9, 20. 14 plus 9, 23, right? 23, right? So one more is, it is earlier 1 to 5 is infinite, 23 is the less than, but you have to write 23, same time you have to think any alternate paths are existed or not. You check it. 1 to 3, 9, 3 to 6, 2. So 9 plus 2, 11, 11, 6 to 5, 11 plus 9, 20. So 20 we got, 23 we got, 20 we got. So among 23 and 20, 20 is the minimum as compared to the infinite. So you write 20 over here. So then 11 is already relaxed 11. So now you can relax the one of the vertices, either 4 or 5. Because it is a 20 and 20. You can take either of one, left or right, it doesn't make any problem. So you take the 20 is the minimum. Then you write 1 comma, 2 comma, 3 comma, 6 comma. What is the 20 associated? 4. Right. So now 20 associated is a 4. So what else is left again? Again 7 you already relaxed, 9 is you already relaxed, right? 20 is already relaxed, 11 is already relaxed, right? So next what is left is only 20 is relaxed. There is no other pass, only 20 get relaxed. So then you write 1 comma, 2 comma, 3 comma, 6 comma, 4 comma, 5. So these are the shortest path from one to other places. So what is the shortest path? Like you can see here, shortest path. So what we got out answer is 1 to 1 to 2 3. So that means that 1 to 2 to 1 to 3. So this 3 and 1 to 2 3 6 4 5 6 4 5. So 6 is a 1 to 6, 4 is a 2 to 3 to 4. Don't add this one, right? I'll show. Don't add this one. Next 1 2 3 4 5. 5 is there, but 4 to 5, right? 4 to 5. So you add this 1 to 5. So these are the path. So that means that 1 to 2 is a 7, 1 to 3 is a 9, right? 1 to 11, this is 11, and this is a 6 to, this is also wrong. So you shouldn't add this path. This is which is a minimum. This is not minimum. So you add this path, like this path. So this will be the 2. So this is the 9, right? So these are the answer for given problem. So main idea they discuss the algorithm is the, like for example, if we are at this position, so we want to find the distance to the some other places, right? So scenario is we want to find the other places like here, here, here. So in that case, what I will do, he will assuming that he didn't explore these paths, right? So that's the reason it is assuming that it is a infinite is the distance. So distance itself is a 0. So this is the major motto in the discuss the algorithm, right? So now we will see the simple example algorithm. So how it is work, right? So now these are the relaxation. So what we found till now we discussed, these are the relaxation. We will see one small example, then you will understand clear how it is discuss the algorithm will work, right? So now if distance of u plus cost of u comma v is less than distance of v, then distance of v equal to distance of u plus cost of u comma plus cost of u comma v. So that means that here u is the starting vertices, v is the destination. So u comma v is the starting and ending vertices, or we can say source and destination vertices. So these are the major idea for developing this algorithm. So next one is cost of distance of v. So distance of v is the destination. Initially we understand that from, for example, here it is starting position, this is the destination. For example, u, this is a v. So we are at this position, right? So initially we don't know, it is a infinite. We are assuming infinite, but actual what is the distance? What is the distance? Let us say it is a 10. So 10 you are assuming, this 10 which is already existed, so that is the distance of cost of u comma v. So distance of v means it is a infinite. So these are the major difference between these two. So we have to understand one thing, this where you are starting, that is a u, this is the u comma v, right? So u comma v, which is the actual, it is 10, but we are assuming that it is a infinite, right? So this 10 is the cost of u comma v. So this infinite what you are assuming, that is the distance of v. Okay, so these are the major difference. Then what is the condition? Distance of u plus cost of u comma v is less than distance of v. So what is the cost of u comma v? It's 10. So distance of u itself, u means where we are at position u itself, again same location, it is a 0. So 0 plus 10 is less than distance of v. What is the distance of v? Distance of v is a infinite. It is a infinite, right? So 10 is less than infinite, then execute this condition. Okay. So these are the major intuition for relaxing the node. Okay. I hope understand the student. We will see the small example for this problem also, relaxation, so that you will understand the major idea in a distance vector, Dijkstra algorithm, right? So now next video, in a next video we will see the small problem to solve this code. Then we will discuss about this time complexity. We will discuss how time complexity of discuss the algorithm, how it is E log v, and we solve the simple problem, and simple problem at the end we discuss the time complexity. Okay, so this is that's all from my side, this simple example. If you like the content, please subscribe my channel and same time share to your friends and peers also. Okay, so thank you for watching. If you have any doubts and queries, you can ping into the comments box. Thank you for giving opportunity. Right. Thank you.